Hi, I'm Esben and welcome to this video on working with vector data in QGIS, where we will be focusing on proximity and overlay operations. So what some people call geoprocessing. These terms, they're not really defined, and some people use some terms for some of it. So it's a bit unclear what we mean by geoprocessing, but in general we'll be looking at proximity, that is finding things that are nearby each other, and then overlay. Overlay has its name from the way that it was basically invented, that you have see-throughable layers. So you have a layer with soil data and a layer with municipality layer or any other form of planning, and then you can place the two layers on top of each other and see which areas intersect, that is, occur in both layers, or which layers are covered in one or the other, or which layers are covered in none of the two layers. So those are those simple overlay operations, therefore the name overlay. And the term overlay is commonly used. If we look at our data and how we work with it, we have in another video covered all those attribute-based tools, and what we have been focusing on today is those spatially oriented tools, especially buffering and overlays as the two primary tools. There are lots and lots and lots of these tools. Even in the standard QGIS with no extensions loaded or plugins loaded, there are more than enough tools, and many of these tools are really just useful shortcuts for all of the tools. In reality, most of the things you can do can be done using a buffer and a union tool and the SQL. Those three tools can do about 80–90% of these type of operations. But in QGIS, all of these tools are collected in the vector menu. We are talking about vector data, and down at the bottom of the vector menu we have these tools here: the research tool, the geoprocessing tool, and the data management tool, which are the main tool sets for working with this. From the data management tool, there's especially one called join attributes by location, which is often used if you want to find out which municipalities or which postal codes some points belong to. So then we'll be using a join by location. So it's just like the join by attribute, where we see this attribute fits together with this attribute, but here we say we are going to combine the attributes from two layers based on that they are sharing geometry, so that the points are inside a polygon or on the line or things like that. So join attributes by location is commonly used if you have a series of point data that you want to have coded in relation to some polygon. So which type of soil are the water wells on, or that type of data. In the research tool, we will primarily be looking at the select by location. That is a typical choice you use very often. For a bit more advanced things, you might also be using random points, but the select by location is a very commonly used tool. Oops. And then over in the geoprocessing tool, that's where the main lot of the tools are. Convex hulls are not so commonly used. They are used if you have some point data and you want to have generated the area inscribed by those points, then convex tools can be used. buffers, intersections, unions, symmetrical differences, clips, differences are, let's say, the buffer tool is a proximity tool that generates an area around a point, a line or a polygon, so it creates a little buffer area. So that can be used to say what is within 500 meters distance of a station. That's where we typically use the buffer tool. The intersect, the union, the symmetrical, the intersect, the union, the symmetrical difference, the clip and the difference, and the dissolve. The intersect, union, symmetrical difference, clip and difference are all what are classically named overlay operations, and we'll cover them in a short while. The dissolve tool is a tool that you use for cleaning up your data afterwards. If you have polygons that through all of these different processes have been clipped into small ones, and you want to gather them together into larger polygons that share a common attribute, that's where the dissolve tool comes in. But that's not the focus of today. The focus of today are most on the buffer and the overlay tools. Before we look at these overlay tools, let's remember from a previous video where we talked about attributes and working with SQL for generating filters, that we are working with set theory. And the basics of set theory is that we have two sets, an A and a B, and then we have these different elements in it. We have, if you say that something is an A and B, then we have this common area or the intersection. If it's A or B, we have both of them, which we call the union. We have a B but not A, and we have a XOR B. We haven't used that in SQL, but it is there. That is that if you can have areas that are close to a station and areas that are close to a park, but you're not interested in the areas that are both close to the park and the station. So an XOR. So of course that the X is exclusive, so that's the OR exclusively in one or the other. And then there's a NOT, but if it is anything that is not within a station, within a distance of a station, that's the NOT. So all of these are the basically logical or set operations, and we'll see we can recognize the names again from the overlay operations: the intersect, the union, the symmetrical difference, and the knots, which are the differences. So, or arrays. So these are the basic tools that occur both in the logical when we're working with attributes in the SQL and when we're working with spatial. So it might help you when you start thinking about what tool to use. Make sure that you have that relationship between what they're called when we're working with attributes, the ANDs, ORs, the NOTs, the XORs, and then what they are called when we are working with spatial data, the intersect, the union, because they are basically just two names for exactly the same. If you look at the common overlay tools, we have the intersect tool, which given two layers gives us the intersection of the two layers. But what you should be aware of is not just an area here, it's the unique combination of the two layers within this intersecting area. So here we have in the blue layer we have two polygons, and in the yellow we have one polygon, and in this output we have two polygons, which are the unique combinations of the two input layers. And note that the output layer, the intersect, will have all attributes from both input layers. Somewhat the same with the union. We have again our two input layers, and again with 2 polygons in one layer and 1 polygon in the other layer. In the output, we can get all unique combinations. So we have 1, 2, 3, 4, 5 polygons, which are then the unique combinations of those 2 layers. So it's not only just the areas that are returned, it's unique combinations of the layers within these areas. And of course our intersect and our union tool both compare to the and the or tool or command in the SQL. Then we have the clip tool, which we might call a somewhat the same as our intersection tool. We have spatially our input layer and our clip layer, and what we get is the input layer inside the clip layer, but it doesn't have any of the attributes from our clip layer. So the clip layer simply functions as a cookie cutter that cuts out the area of our input layer. So spatially, what area is covered of them would be exactly the same as intersect, but without the attributes from the clip layer. And finally, we have our symmetrical difference, which is also sometimes called the erase tool, and it functions just like our cookie cutter but opposite. That the cookie cutter or the clip tool returns the layer that is inside the cookie cutter, while our symmetrical difference returns the layer that is outside. So it cuts a hole in it. That's why it's also sometimes named the erase tool. Finally, we have our proximity or buffer tool, and basically it's very obvious what it does. It generates a buffer area around the point line or polygon. There's one thing you should be very aware of, and that is that there is a dissolve option. So because we typically or let's say especially if we are buffering lines, a road network, and want to count how many addresses are within a disturbance distance of 500 meters from a road network. Well, in that case, if we just use the buffer tool without the dissolve area, the addresses that are in this common area in here will be counted twice, because they are both in that polygon and in that polygon. So because that is so common a problem, there is an option in the buffer tool that's called dissolve, and then generates, instead of a buffer area for each feature in the input layer, it will generate a buffer that is common for all of the features, and therefore will not have a double representation of that common area where the 2 lines meet. So that's the only little tricky thing about the buffer tool. So let's look at how these tools function in QGIS. I'll try and show the use of these tools through a simple little example. I have taken from the Danish topographical dataset, that's called T. I have taken some information here. I've got the airport, this is Copenhagen Airport. It has some runways, landing span on it. I should mention that there is some small dots of runways because they're heliports. There's one on top of the main hospital in Copenhagen, and there's one out on a little island outside Copenhagen. So apart from the ones in the Copenhagen airport, there are 2 other places where there are runways. Then I have taken all the train stations, and then I've taken all the green areas, the recreational areas of Copenhagen. There are also other green areas, so there's some forest and things like that, which is not here. But let's stick with these recreational areas for this exercise. And what we're going to do is that we want to find places where we would like to live. So we don't want to live next to a runway. Let's say we will have to be at least 1 kilometer away from a runway. That's maybe overdoing it for the heliports, but never mind. So 1 kilometer away from a runway, that's no-go area. We don't want to live there. But we would like to live 500 meters from the station and 500 meters from the recreational areas. So the place we want to live has to be at least 1 kilometer away from the runway and within 500 meters of both a station and a recreational area. Those would be nice places. And once we found those areas, we will find out how many addresses can we then live on in Copenhagen within these restrictions. So the first thing is that we'll use a proximity tool, the buffer tool, to find our zones around our runways, our stations and our recreational areas. So we go up into our vector processing and geoprocessing buffers, and we will take our runways and we will say 1 kilometer, so that's 1,000 meters from our objects. We could also have an attribute in the layer that decide if we had different noise levels or things like that. We could have an attribute in the one that we are buffering that decided how big the buffer should be, and we will save our output as runway 1000 and do that. So that's the areas around the runways. Of course you can see this overlapping phenomena here. So if I had chosen dissolve and call it runway 1000 dissolve, we will see that they are all merged together into one polygon. So that's the difference between using the dissolve and not using the dissolve. Then we wanted to do the same for our recreational areas, but only 500 meters. And I'll just call it recreational 500. And our stations I'll call station 500. So the areas that we would like to live in are covered by the station 500 and our recreational 500, but do not are not allowed to be inside these green areas. So those are the nice areas we would like to live in. So first of all, we want to say that they have to be both within the distance, appropriate distance of our stations and our recreational areas. So we'll go up and do our tool again, also a geoprocessing tool, and use the intersection because they want to have both within our near to station areas and near to recreational areas. So we want the intersection of our recreational and our stations and call it OK locations. So once that's done, we can now see that we have our OK locations. If we get rid of all of these elements here. So these are OK locations. However, some of these OK locations are covered by the green ones. So we want to get rid of those. and therefore we can use the other tool down here. So we can use we won't use a clip because use that for later, but a difference here. So the area that is within our OK but not within our airport areas. So we'll do our OK areas and our one-way 1000, we might as well use it to solve, and call them final locations. And now you can see that the only thing that has happened is that this little area has been chipped off here. So that's fine, that's all our final. So we want to live in one of these places. Now let's look at what addresses we have for working with this. So if I go down and load from the earlier exercise where we worked with attributes and did joins and things like that, we had some access addresses. We might as well just use them. So these are our access addresses in Copenhagen. And what we're interested in is those addresses that are inside our final locations. And here we have not less than 3 solutions we can choose from. We could go to our vector and then we could say intersect. Okay. If we use the intersect of the 2 layers, we will find those addresses that are inside our final locations, and we'll get the attributes from both layers. We could use the clip tool and clip those addresses that are inside our final locations. In that case, we'll get the same points, the same addresses, but we will not get the information from the final location layer. And finally, there is one that is not a bit different, so therefore I'll choose that to show it. From the search tool, we have this select by location. That doesn't generate a new layer, but it generates a selection set, which is generally faster, but does not save it to a file. We can do that later, or we can use it as a basis for further analysis. So in this case, I'll just use the select by location tool. But before I can run my select by location, I have to do a wee bit of housekeeping. The problem is that there are tools in QGIS that cannot work with a layer such as this final location. The problem is that if I click on one of these elements in final location, this one, you can see that they all will be selected. This is what one calls a multi-part file, because all of the is one object that consists of multi-parts. And in earlier versions there were lots of tools that did work with this, but still in this version, which is 2.10, we still have a problem with some tools that cannot work with multi-parts. So what one has to do is that we will have to first convert these to a single part, so that each connective area will become one object. And in general, that might be a good idea to do after you've done buffers with a dissolve on it. So we go on to vectors, and then we go down to the geometry tools and use multi-part to single part. You run it on our final location, call it final single part, and run that, and you can see it's already there. And if I now, with this layer here, click on an object, you can see now it's only that one that is selected. So that's the difference between the original one here. If I select one of those, that's the multi-part version, all of them got selected. If I do the same with this layer, it is only, oops, I had to go up there, this one that is selected. So this is a single part layer. I just make sure that there's nothing selected, and then I can go and do my select by location from the research tool, select by location, select from addresses that intersect with my find locations, and run that tool. Close it. If I now turn my locations on, we can see that all of those locations that are yellow, they are locations that meet our criteria. And if we want to save that down to a file, we can do a save as. And in the save as dialog box, remember to save only selected features, and then we'll save it in our file and call it final addresses. And now we have, if I get rid of all these, you can see we have all our final addresses, and they're all inside these ads at our final locations. So the whole process has gone right. We have now found those places where we would like to live. I hope you liked the video. See you. Bye.